Now let's go for the third normal form. Third normal form says that is all about transitive functional dependency. What is transitive functional dependency? Now, in a transitive functional dependency, a condition where A, B, C are the attribute of a relation such that if A determines B, B determines C, and C is transitively dependent on A via B, then we have the transitivity dependency or transitive dependency. What it says? It says that if A determines B, B determines C. So with the help of transitive dependency, we can get A determine C. Yes. So this dependency we can get from the transitivity rule. So we have the transitivity rule. Based on that, I can find out A determines C. Now what third normal form says that a relation that is in first and second normal form in which no non-key attribute is transitively dependent on the candidate key. What it says? It says that there should be no non-key attribute transitively dependent on the candidate key. Now you assume that this is my functional dependency. You assume that I have a relation A, B, C, okay? And I have functional dependency, A determines B, B determines C, right? Now, this is my functional dependency with this table. Can I say this table is in third normal form? So for that, I have to fulfill the condition. What condition? It says that that should be in a first and second normal form. So can I say that it is in a first normal form because we doesn't have the data given. So I cannot say that which one is and I assume that it is in the first normal form because the data is not given. Based on the data only, I can say that whether the data is atomic or not. Now let's go to the second normal form. Second normal form says that there should not be any partial functional dependency. Let's go to the second normal form. Now for that we have to find out the key. What is the key? Now to finding out the key, I'll find out the closure. I'll find out A closure because I'll find out the closure of all the determined part and then I'll get to know that which one is the key. Now what is A closure? A closure is A is determining B, B is determining C. So I got all the attribute which is equal to R. Can I say that in the candidate key list, A is one candidate? Yes. Let's go for B closure. So B closure is B. B is determining C. Can we go further and find out A? No, it is not equal to R. It means that B is not a candidate key. So which is a candidate key? A is a candidate key. If we have only one candidate key, means it is a primary key. Sorry. So it is a primary key. So what is a primary key here? Primary key here it is A, right? A is the primary key. Now, if we'll take A as a primary key, can we say that there is a partial functional dependency in the table? So what is partial functional dependency? Part of the key is determining some non-key. So in this particular functional dependency list, do we have any part of the key? Because A is atomic attribute, there should not be any part. So it is in second normal form. So I can say that this relation is in second normal form. Now let's go to the third normal form. So up to first, second, it should be there. So it says that if you are thinking that your table should be in a third normal form, so it should be in a first normal form as well as in the second normal form. So we find out that it is in second normal form. Now let's go for finding out whether it is in third normal form or not. Now third normal form says that no non-key attribute is transitively dependent on the candidate key. No non-key attribute means if we have any dependency like this, non-key attribute is determined by any key attribute. If key is determining some non-key, and this functional dependency, I find out from which rule? Transitivity rule. If I apply the transitivity rule and then find out key is determining some non-key, then there is a problem. Okay. Now, can we find any functional dependency applying by transitivity rule? So here you can say A determine B, B determine C, A determine C, I can find out. So A determine I have find out by the transitivity rule. Is this functional dependency is in this mode? Key is determining some non-key? Yes, it is in that mode. It means, what does it mean? It means that this particular relation is not in third normal form. So what we have to do? What we have to do? We have to split. Now, how we can split? How we can split? We know that this particular functional dependency is not in third normal form. Why? Because we find out a transitivity with the transitivity rule, we find out a functional dependency which is of this type, means key is determining some non-key. Means I have some issue. What is the issue? The issue is with A determines C, right? So what I'll do? I split the table in such a way so that the problem will be resolved. So this R, which is having attribute A, B, and C, will be divided into two, R1 and R2. In R2, I'll put those attribute which is creating problem, which A and C. So I'll put A and C in one attribute in one table, right? And another table I'll put A, and then we have B. Now for this, what is a functional dependency? A determine B. For this, what is a functional dependency? A determines C. Can we find any transitivity rule from this? No. Or can we find any transitivity rule, apply transitivity rule here? No. Because we have only one functional dependency here, one functional dependency here. You see this functional dependency, this is functional dependency 2, this is functional dependency 1. One is preserved, 2 doesn't preserve. So as I told you, up to second normal form, we can preserve the functional dependency. Beyond that, we cannot preserve the functional dependency. So here with this particular function, in this particular table, which is R1 and R2, we can say that R1 is preserving functional dependency 1 and R2 is preserving the functional dependency which was not given, and we find out with the help of transitivity rule that is there. Now this table R1 and R2 individually are in third normal form. Why? Because we don't have any non-key attribute which is a transitively dependent on the candidate key. Here what is the candidate key? A is the candidate key. Here what is the candidate key? A is the candidate key. Means A is the primary key, A is the primary key. This primary key is determining non-key, which is not find out by the transitivity rule. It is the part of this particular table, and this is the part of this particular table. So I think you understood the third normal form. So third normal form says that if we'll apply the transitivity rule into the given functional dependency set, and we find out that any key is determining some non-key, then we have to split the table. And then we'll split the table in such a way so that in a new relation, there should not be any transitivity dependency which will hold non-key is determined by the key attribute. So this is your third normal form. Let's see this example. I told you the simple example. Let's see this particular example and try to understand. Now this is employee relation or employee table where we have employee number, employee name, department number and department name. Now we have two functional dependency. First is employee number is determining employee name, department number and department name. And department number is determining department name, right? Now let's go and see in the simplified form. Let's make it A, B, C and D. So what is a relation? We have a relation with the attribute A, B, C and D. Now the functional dependency which is given is A, which is determining B, C, D, and we have again uh, C, which is determining D. Okay. Now identifying transitivity dependency. Now here employee name B, which is then department number and department name are non-key attribute. Department number determines department name. Department number determines department name, a non-key attribute, and department number is not a candidate key. So here we find out that is this relation is in third normal form. It says that this relation is not in third normal form. We'll find out why. Is the relation in second normal form? Is the relation in second normal form? So for that, we'll find out the closure. What is A closure? A closure will be A. A is determining B, C, D, which is equal to R. Means we have the candidate key A. C closure, what is C closure? C closure will be C. C is determining B, D. So D will be there, which is not equal to R. It means that we have this candidate key and this is the primary key also. This is the primary key also. Okay. Now, if A is the primary key, then what will happen? If A is the primary key, then what will happen? So you can see here, if we'll decompose it into A determine B, A determine C, A determine D by decomposing rule, and C determine D. Okay. Now, with the help of all these functional dependency, we find out some functional dependency like this. A determines C, C determines D, and A determine D. Now we find out A determine D with that transitivity rule, which is already there. With the help of transitivity rule, we find out a pair like this, key is determining some non-key, which is already there. So, so this is becoming a problem for us. Which one? A determined D is becoming the problem for us. So what we do is we'll put A, D into one table and the rest of the attribute which is A, B and C in another table. So it will become R1 and this will become R2. Let's see. So the department number, department employee name and department number means A, B and C in one table, and here we have department number, department number is C and D is in one table. Okay. So here the splitting is in the other form, means which particular function dependency, because of which particular function dependency, we are getting the other functional dependency which is creating the problem. So because of that, we are getting the problem. So because of that, we are getting the problem. So, so here it will be like this. It will be like this. So CD in one table, because this particular function dependency is creating the problem, because of which we got A determined D as a separate functional dependency. So CD will be in one table, and rest of the attribute are in one table. So A, B, C will be in one table. Here CD and CD is of attribute, sorry, functional dependency. Here A, B, C, and D. Sorry, A, B, A determine B, C will be in one functional dependency because D doesn't exist. So for this will is this exists the third normal form. It is also in the third normal form. And now I can say that the R1 and R2 is in a third normal form. In the same way, what example I have told you here, A determine B and B determine C, we are getting A determine C, right? Now, for because of which functional dependency we are getting the problem, we are getting the problem with this functional dependency, which is B determine C. So here also we have splitting criteria will be like this. So I'll put AB in one table and BC in another table, right? So here we have functional dependency 1 exists and functional dependency 2 exists. Okay, so here also we are preserving the functional dependency in some cases, not in all cases. Here, as you can see, here the first functional dependency doesn't exist. What is the first functional dependency? A determine B, C, D. What is the second functional dependency? C determine D, which exists. So functional dependency 2 exists, but functional dependency 1 doesn't exist because D is not here. So in some cases, I am preserving the functional dependency like this, but in some cases I am not. Right? This is your third normal form. So to how we are splitting it, it is the way how we can do that. In a partial function dependency, we'll find out that function dependency which is creating the problem. Here also in the third normal form, we'll look for those function dependency which is creating the problem, because of which we are getting a transitivity um, functional dependency, or with the help of transitivity rule we are getting the functional dependency. So here also we have to find out those attribute which is creating the problem. Okay, so in both the cases you got it here. Because of this we are getting the problem, and the problem is this. And because this we are getting the problem, and the problem is this: A determine D. So A determines C is there, which is a non-key and uh, sorry, key and non-key combination. But here some non-key is determining some non-key, right? Because of that, we are getting the other attribute, and which is having the problem. So this has to be gone from the table CD. So CD will coming here. Here also, because of this BC, there is a problem. So BC has to be in a separate table, right? So this is your third normal form.